Hello. We're broadcasting live from our studios located in the penthouse of the physics tower which sits astride the magnificent Wellesley College Science Center. In this worked example, we're going to get some practice with vectors. We're going to tell a little story problem, and it's going to be a geography problem that involves three different cities: Toronto, Detroit, and Washington. And in the problem, we're given information about how Toronto and Washington are each positioned relative to Detroit, and then we're asked to deduce something about the relative positions of Washington and Toronto. And it turns out that the mathematics of vectors is very useful in answering such a question. Okay, so using the information given in the problem, I'm going to translate those words into a picture. And here's the picture I want to draw. I'm going to draw a set of coordinate axes, and I'll label them y and x. And since things are being measured relative to Detroit, I'm going to put Detroit at the origin of my coordinate system. And Toronto, we're told, is 320 kilometers northeast of Detroit. So I'm going to put a little dot somewhere in the upper right-hand quadrant to represent the city of Toronto. And I can represent the location of Toronto as a position vector. So I'm going to draw an arrow from Detroit towards Toronto, and I'm going to label that vector R sub t, and that stands for the position of Toronto measured relative to Detroit. And the length of my vector, we're told, is 320 kilometers, and the angle that this vector makes with the horizontal axis is 26 degrees, because we're told that Toronto is 26 degrees north of east. Similarly, I can put another dot which indicates the position of Washington. And Washington is located south of east, so I'm going to draw Washington in the lower right-hand quadrant. And I'm going to draw my vector indicating the position of Washington with respect to Detroit. We're going to call this vector R sub w. And we're told in the problem that this vector is 625 kilometers long and makes an angle of 39 degrees with respect to the horizontal or easterly direction. Okay. And we're asked to deduce information about the relative position of Washington and Toronto. So we're asked, if you start in Washington and take a trip to Toronto, how far do you have to go and in what direction do you have to head? And we recognize that in this drawing, what I'm really being asked about is the displacement vector that connects Washington to Toronto. So this vector that I've just drawn represents a change in position. It's the displacement if you start in Washington and end up in Toronto. So I'm going to call that vector delta r, and we're really being asked in this problem to calculate delta r. And what you can see from looking at this diagram is that mathematically, if I start in Detroit, I take a trip to Washington, so I've changed my position by a vector r sub w, and then I take another trip with a displacement of delta r, I end up in Toronto. So mathematically, the way we can write that statement is to say that the sum of the vectors r sub w and delta r is the same as the vector r sub t. In other words, if I start in Detroit and go through Washington and then take a trip to Toronto, I end up in Toronto. Now, I can rewrite this last equation. We're being asked in this problem to find delta r, information about the displacement. So I want to solve this equation for delta r, and I can just rewrite this as delta r is just the difference between r sub t and r sub w. because we're being asked to calculate something that's a difference between two vectors, it'll be most convenient if we express the vectors RT and RW in Cartesian coordinates, because as we'll see, it's very easy to subtract vectors when they're represented in Cartesian coordinates. So I'd like to find the Cartesian coordinate representation of each of these two vectors RT and RW. And we're essentially in this problem given information. We're given information about these vectors in polar coordinates, and now we've got to convert to Cartesian coordinates. So to find the Cartesian representation of the vector RT, I just need to find first the x component, and looking at the above drawing, we see that the x component of the vector RT is given by 320 kilometers times the cosine of 26 degrees. And similarly, the y component of the vector RT is 320 kilometers times the sine of 26 degrees. Okay. I can now calculate the Cartesian coordinates of the vector RW in a similar fashion. R sub W, the x component is a positive number. It's given by 625 kilometers times the cosine of 39 degrees. And now here's a somewhat tricky part of the problem. The y component of the vector R sub W is actually a negative number. This distance here is a negative number, and I've got to explicitly put that negative sign in, and the magnitude of the y component is 625 kilometers times the sine of 39 degrees. Okay, now I'm in a position to calculate the difference between these two vectors. Delta R, remember, is RT minus RW. And I'm going to, I did these calculations offline. The x component in Cartesian coordinates, RT has a value of 288, 140 kilometers. And when we do the mathematics for RW, we find that the components are, the x component is 486, and the y component is negative 393. And throughout this problem, in the interest of space, I'm leaving out the words kilometers, but all these numbers in this line, all these components are, of course, in units of kilometers. And then to subtract two vectors, all I've got to do is subtract component by component. So the x component of delta R is obtained by taking 288 minus 486. And the y component of delta R is obtained by taking 140 minus negative 393. So we conclude that the vector delta R, the displacement from Washington to Toronto, has a value of minus 198, 533 kilometers. Okay, so we're almost done. A result, remember, is that the displacement from Washington to Toronto is represented by the vector delta R, which in Cartesian coordinates have a value of minus 198, 533 kilometers. But the question asks us for distance and direction. So that's the English language's way of saying, I want your answer in polar coordinates. So we just need to convert our answer into polar coordinates. So I'm going to do that with the help of a little drawing here again. I'm going to draw another set of axes. And I'm going to place my, might as well label these axes. This is Y and X. And I'm going to draw my vector delta r on these coordinate axes with the tail of the vector emanating from the origin. So delta r will look something like this. Notice it has a negative x component and a positive y component, so delta r points into the upper left quadrant. And in this figure we can label two distances here. The horizontal leg of this right triangle that I've just drawn has a length of 198 kilometers, and the vertical leg of the right triangle has a length of 533 kilometers. And we're being asked for the length of this vector delta r, so that's the hypotenuse of the right triangle. So, and that length represents the distance from Washington to Toronto. So I can write that the length of this vector delta r, or its absolute value, I can just use the Pythagorean theorem, and that length is given by the square root of the sum of the squares of the two legs. So it's the square root of 198 squared plus 533 squared. And I plug those numbers into my calculator, and I find out that Toronto lies a distance of 569 kilometers from Washington. And if I want to know the direction, well, I can describe the direction in terms of this angle, which I'll call theta, and we see from the triangle that the angle theta can be obtained by calculating the arctangent of the ratio of the opposite side to the adjacent side. So it's the arctangent of 533 divided by 198. And if I plug that number into my calculator, I get an angle of about 70 degrees. So that tells us that if I want to start in Washington and end up in Toronto, I better head off in a direction that's 70 degrees north of west. Okay? So that we did, and we did it without even consulting Google Maps.